to our simulation. So our topic is Selective Repeat ARQ protocol. We are using a Python code to run this program. Selective Repeat ARQ is a network protocol used to ensure reliable data transmission over unreliable channels. It's one of the most efficient error control mechanisms used in computer networks. This is the client code. Up to here, this is the client code, and from here it's the server code. So let us run the program. This is our simulation window. Let me explain the parameters. Total frames. This is the total number of frames used in the simulation. Currently there is 16 frames. You can see from 0 to 15 there is 16 frames in the simulation. Window size. Window size is actually the total number of frames grouped together and sent to the server. In this window size is 4. The highlighted part are the frames 0 to 3, which is the window size, and there is the other parameter loss. By this we can reduce or increase the loss percentage, and speed is in milliseconds. We can reduce or increase the speed using this, and there are several functions in the simulation like start, pause, and step, in which you can show the step-by-step simulation, and stop, reset, which will terminate the entire simulation, and we should start the simulation from first, and apply and reset, which is used to change the parameters. We should change the parameters. For example, like I kept the frames as 14, and now I will apply and reset. So you can see there is only 14 frames in the simulation. And export trace, it is used to export the messages in the message box, which are the steps that we have done in the simulation. Let me give you 3 examples. Before that, let me explain the colors which indicates the simulation on the frames. For example, if the frame has been not sent and is still in with the sender, it shows gray color. The frame will be gray color. And if the frame is in transmission, it's not actually yet received by the server, it will be in yellow color. If the server receives that frame, it will be in blue color. And if the server received the frame and it is acknowledged by the server, then it is sent back to the client, which is green color. And if the frame is lost or has to be retransmitted, then it will show red color. So these are the colors. You can see the function of these in the simulation. Let me give the first example. So this is the first example. Let me change the frames to 15 or 16, and the window size, let me keep it 3, and actually it's let me reduce the loss percentage, yeah, 0.15, and speed, let it be 700 milliseconds. Let us so we should apply and reset. As you can see, there are only 16 frames in the simulation from 0 to 15, and the window size is just 3. You can see the highlighted part. Let me run the simulation. As you can see, once the simulation is done, there are all green frames, which means that are already acknowledged by the server. As we have kept the loss percentage to bare minimum 0.15, there are currently less number of red frames in the client. This is one kind of example. Here you can see all the frames are finished and acknowledged by the server. All the frames are sent and also acknowledged. So here there is no loss of any frame, or any frame has to be retransmitted. This is the first example. Let us come to the second example. Here I have taken 12 frames. As you can see, 0 to 11, there are only 12 frames, and the window size is 5. The highlighted part from frame 0 to 4, it is the window. And the loss percentage I have taken 0.5, and the speed I have taken 900 milliseconds, so you can understand better. After that, we have to apply and reset, and let me start the simulation. As you can see, the packets are sending from the client to the server. Here the blue color refers to the server received. As you can see here, we have received a red frame which shows the frame has been lost or it has to be retransmitted. Even if it tries to retransmit, it is not acknowledged by the server. Here, as you can see, there are two red frames. It suggested that two frames has been lost. Here you can see the thread has been stopped, and here you can see frame 11 is lost and other frames are received by the server. And you can also see here the frame 7 and 8 is lost, which is again sent, sending acknowledgement for 7. Then the 7th frame is received. So this is the second example. Let me show you another example which has more loss percentage of frames. Coming to the third example, let me increase the frames this time. Let me increase it for 18, and window size I'll keep it 3. Loss percentage I'll increase tremendously. Let me keep it 0.8, and speed let it be 900. Now I'll apply and reset. As you can see, there are total 18 frames in this, and the window is only 3 frames from 0 to 2. Let me start the simulation. We can also show this stimulation from step by step using this step option. You can see in the first step, one frame is lost. Here the frame 2 is lost or has to be retransmitted. We can see the second step. As you can see in this, the frame 2 is completely lost. It has to be retransmitted. Like this. You can also show step by step. As you can see, when we pause the simulation, here it shows paused, which is the on-time simulation. And let me start the simulation again. Here you can see all the simulation that is happening. As you can see here, all the 3 frames are lost, so it took so more time to again send and resend the frames. Uh, Here the number of frames that are lost or has to be retransmitted is more, as we kept the loss percentage to 0.8. Here you can see the every simulation step that is happening in the message box. So the simulation is completed. As you can see, there are more number of red frames, which indicating that more number of frames are lost or has to be retransmitted. This is a third example. If we want the export the message box and the steps that has happened, we can select export trace, which will be saved as CSV files. And this is the whole selective repeat ARQ simulation. Thank you for watching.